Hey folks! Welcome to the third installment on my EarthGames project. Watch the first two to get the full story on my design process. For the first half of this video, I'll talk about how to stay on track with your project. As you may have noticed, this video comes about 3 months after the last one. Motivation comes from goals. From the previous videos, you may have gathered that I set small goals and accomplish them one at a time. First, I decide to make a sphere. Then I make it rotate. Then I put a map of the Earth on it, and so on. In accomplishing one of these goals, I came up against a seemingly insurmountable obstacle. When you reach one of these, you should reevaluate your options. This is something I didn't do. Instead, I let my stubbornness get the best of me. In my mind, I had to complete this goal before I did anything else. There are a few options available when you come upon this problem. One is that you can abandon the project if the goal is crucial to the success of the project. To make this option worthwhile, of course, you should immediately start working on a different project. Otherwise, you might as well go with option number 2. Keep working on the problem. Do whatever it takes. Ask on a forum, watch a tutorial, look for some example code. In taking this option, you have to consider how long this will take and how many resources you're using up. Because the sad reality about being a designer is that resources are limited. You have to consider what's stopping you from taking option number 3. Just let it go. Pick another goal. Take the project in another direction. Your project doesn't have to be perfect, and it never will be. This is what I realized in the past week. The problem I was trying to fix wasn't integral in the grand scheme of things. All it was doing was holding me back from accomplishing all the other small goals I had in mind. This was the last video I recorded before I ran into the problem. I wanted to fix the graphics. What bothered me was how the pixels would overlap each other in the center. As you can see, they often wash over each other when one comes in front of the other. But this is a truly unimportant detail, so I will leave it off to the side for now so I can get some good work done. This is the end of the design portion of the video. If you're interested in mathematics or programming, continue on as I show off some of the new mechanics I've implemented, explain the math behind them, and look at some of the code. Most of the new features that I added have to do with user interaction with keyboard and mouse inputs. And one of the features that I added in a previous video was the ability to drag the globe around with the mouse. And this is a feature that I didn't really explain in detail, so I thought I might as well cover it here. Normally this sort of behavior relies on some sort of event system, where you create an event object and add it onto some sort of stack. But Unity has a really nice way of dealing with user input. This is the general format that I use to gather user input that I've found helpful. I'm not sure if this is a universal paradigm in Unity coding, but it's what I use, and it works really well, and it's really easy. So, it all happens within the update function, which is something you'll get in every script. Now, if you're unfamiliar with this function, you will become very familiar if you learn some Unity code, but basically what it does is this runs every few milliseconds or something like that, which makes it really handy for what we're trying to do here. Any kind of user interaction is going to be something that we're going to try to listen for. We want our program to constantly be checking. Has the user made this action? Have they pressed this button? And usually when we're asking a question in a program, that comes in the form of an if statement with a conditional inside. So that's what we're going to do here. We're going to put an if statement And then we're going to have some sort of input Boolean function. These are built into Unity, and they're really helpful. Input dot something. There. And this will return true if a button is pushed down, or if it's just been pushed down, or if it's been let go, whatever you put here. And then in here, you just run whatever code you want to run when a key is pressed, or if there's a mouse click, or whatever. So now let's go back to the project, and we'll just go over the mechanics that I've added one at a time, and I'll show the code that's associated with each input behavior. Let's start with the simplest behavior, which has to do with a mechanic that you've already seen in this video, which is the political map, which I'll talk about briefly at the end of this video. What this behavior does is it checks if the keyboard button P has just been pressed down, and if it does, it toggles this political boolean, which tells my program how to render the colors of the globe. And I also switch on this update colors boolean, which will prompt my program to update the colors so that it doesn't have to update the colors every tick. Here's the dragging behavior, which is also quite simple. If the mouse has just been pressed down, then it turns on this dragging boolean, which tells the program to make the globe rotate to follow the mouse using this pivot, which is set by this function, which returns false if you click anywhere outside of the globe. If you click outside of the globe, you're not really dragging the globe. And then when the mouse button is released, then it sets the dragging to false, which causes the program to resume the default behavior. Next is a bit of a debugging feature, since it's not really meant for the final product, but it's just kind of a cool thing that I decided to add in since I already have the altitude data for it. And what this does is allows you to change the water level. When the W key is held down, the default behavior is to change this shift water variable by how much this function gives back. Now this is a little different from the other input functions that we've seen. It gives back a float rather than a boolean. It gives back some arbitrary value of how much you've scrolled the mouse wheel. And then the alternative to the default behavior is if you're holding down the W key and you press down the middle mouse button, which will cause the shift water variable to return to the default value. And at the end here, I change update colors to true to reevaluate the colors painted onto the globe. Finally, we have the behavior of zooming in and out of the globe. This is the else statement from the earlier conditional to check if the W key is pressed down. If the W key isn't pressed down, then the default behavior is to increment the zoom variable by the scroll wheel amount. And in the alternative case, we have if you press down the middle mouse button, zoom will return to its default value. This last feature you might have already seen. It's that the globe rotates on its own around the axis. This took just a bit of math, but it's very simple math. So I'll just explain it right here. So let's draw a vector from the origin of the globe to the top, to the North Pole. And let's have this vector always point towards the North Pole, no matter which way this globe is rotated. And then let's also normalize this vector so that it's of length 1. When the normal vector is pointed up like this, it has a y-coordinate of 1. When the y-coordinate is 1, we want the globe to rotate around the y-axis. If the normal vector is pointed down like this, then it has a y-coordinate of -1. So we want to rotate the globe in the other direction around the y-axis. If the normal vector is pointed towards us, that means the z-coordinate is 1, which means we want to rotate the globe around the z-axis. If the normal vector is pointed to the side like this, then its x-coordinate is 1, which means we want to rotate the globe around the x-axis. And what's really nice is that if you take all this in combination, and if you make this behavior a gradient, so that if, say, the x-coordinate was in between 0 and 1, then it's a smaller effect of rotating around the x-axis, then it will rotate around the axis. So this turns out to be very simple in code. And that's about all I have to show for now. A bit of a miscellaneous video, but I hope you learned something. One last thing I want to show, but I didn't want to highlight, was a time lapse of data gathering for the political map. I already showed something like this in a previous video where I gathered altitude data, so if you want to learn more about this, check out the first and second part of this series.